Systems of linear equations. We have the following definition. Before we look at systems of linear equations, it will be wise to look at a linear equation in several variables. Well, a linear equation in variables x1 to xm, so a linear equation in m variables, can be written as follows. Is an equation of a type a1 times x1 plus a2 times x2 plus a3 times x3, etc., etc., till the final term am times xm equals some constant b. Here a1, a2 till am are given constants in R, as well as b. An example. We know that a line in R2 is given by the following equation. A1 times x1 plus a2 times x2 equals b. Here a1 and a2 are not supposed to be 0, both. Yeah, it specifies a line in R2. a1 x1 plus a2 x2 plus a3 x3 equals some constant b defines a plane in R3, at least if a1, a2 and a3 are not 0 at the same time. Well, not all types of equations are linear. A nonlinear equation in two variables is, for instance, x1 times x2 plus x3, or three variables, x1 times x2 plus x3 is 1. Well, a solution of the equation, a linear equation star, this is a vector x with coordinates x1 to xm, such that these constants x1, x2 till xm satisfy the condition as set out by equation star. So some other examples. 2x1 plus 3x2 equals 3 represents a line. The solutions of this equation, linear equation, represents a line in R2. Another one. x1 plus 2x2 plus 3x3 equals 2. Well, the solution represents a plane in R3. Recall that we had an example before, x1 plus 2x2 plus 3x3 equals 4, which we have discussed more extensively. Well, now, a system of linear equations is more or less just a finite set of linear equations. And x is a solution to the system of linear equations if it specifies a solution for each linear equation as part of the system. So x is a solution of the system if it solves all linear equations simultaneously. Well, look at an example now. Consider the following system of linear equations. We'll consider two equations, 3x plus 2y plus z equals 1, and x plus y plus z equals 0. And this is a system of linear equations. Each of the equations is linear. So we have two linear equations and three variables, and we call this a 2×3 system. Now focus at the solution. Well, actually, we have the description of two planes here. So in the intersection we find a line. So the solution, a general solution, will be a line. And a particular solution here is, for instance, x is equal to 1 minus 1, 0. Well, just check that both equations are satisfied. Yeah, 3 times 1 plus 2 times minus 1 plus 0 equals 1, obviously. And the second equation, x plus y plus z, if we plug in x, then 1 minus 1 plus 0 makes 0. So indeed, x is a solution to the system.